Hello, this is Terrence McNally. We've gotten used to dealing with folks not only doing things that seem obviously against their best interests or their health, but also inciting conflict and even violence over others' sensible behavior. Here's my 2010 conversation with neuroscientist Antonio Damasio about his book Self Comes to Mind, Constructing the Conscious Brain. Damasio is one of the pioneers who challenged the Enlightenment's vision of mind over body and asserted the primary role that emotion and feelings play in human rationality. In my introduction back then, I said, I can't help thinking that Karl Rove and Frank Luntz based their playbooks on his message that emotions can trump facts. Hello, I'm Terrence McNally. Welcome to Pacifica Radio and Free Forum. Today, we're going to explore one of the big questions. How is consciousness created? And why? And what does it mean once it emerges? Today's guest, Antonio Damasio, has spent the past 30 years studying, in partnership with his wife Hanna, how the brain operates. He's written about it in award-winning and best-selling books that readers can actually understand. In Descartes' Error, Emotion, Reason, and the Human Brain, he took on the Enlightenment's vision of mind over body and elevated the role that emotion and feelings play in human rationality. And I can't help thinking that Karl Rove and Frank Luntz based their playbooks on the book's message that emotions can trump facts. In The Feeling of What Happens, Body and Emotion in the Making of Consciousness, he argued that consciousness is linked to emotion and feelings. In Looking for Spinoza, Joy, Sorrow, and the Feeling Brain, he explored how Spinoza linked mind and body, and thus paving the way for modern ideas of neurophysiology, that idea that you can actually approach neural situations as physiology. And that takes us to the new book, Self Comes to Mind, Constructing the Conscious Brain. In it, and I'm going to sort of summarize it, and then I'll let Dr. Damasio correct wherever I've led you astray. I think he presents compelling new scientific evidence that consciousness, what we think of as a mind with a self, is a biological process created by a living organism. Damasio takes an evolutionary perspective and links the millions of single cells in the human body and brain with single-celled organisms. Organisms, he says, use whatever tools they have to regulate and manage their biological systems in order to maintain the balance or homeostasis essential to survive. Now, as consciousness evolves to what he terms the autobiographical self in humans, life management begins to aim not only for survival, but for well-being. He suggests that the brain's development of a human self opens the way for the appearance of culture, a radical break in the course of evolution that offers a new level of life regulation, what he calls socio-cultural homeostasis. Should this lead to the organism of a society managing itself so that it achieves balance? Well, that's hardly what seems to be going on right now if I look at things in terms of equity, consumption, climate change, and so on. And we'll get to that. On Free Forum, we explore the lives, the work, the ideas of individuals that I suspect have pieces of the puzzle of a world that just might work. We look at new, innovative, provocative approaches to business, environment, health, science, politics, media, culture, all based on the fact that I believe we can do better, and I want to find out how. Antonio Damasio, MD, PhD, is the David Dornsief Professor of Neuroscience and Director of the Brain and Creativity Institute at the University of Southern California. He was elected to the American Academy of Arts and Sciences in 1999 and has been the recipient of numerous honors worldwide, including this year's Hanna Prize, giving to only one scientist each year. Obviously, he is the author of the books that I mentioned previously. And before I bring him to the microphone, I will let you know that he has laryngitis. He's been traveling, and I saw him speak last night at the Hammer Museum, and when he first said, I have to tell you all I have laryngitis, I just went, oh no, what'll happen tomorrow? But here he is. Welcome, Antonio Damasio, to Pacifica Radio and Free Forum.
My pleasure to be here, even with laryngitis. And by the way, your summary of the book was perfectly fine.
Great. Good.
You pass.
Excellent. I like listeners to get a feel for the people behind the ideas and the work that we talk about. So can you tell us a bit about your path to the work that you do? Perhaps how you chose neuroscience, how you chose the questions you pursued, and finally, your move to USC and the establishment of the Brain and Creativity Institute.
Well, it's a very, very long story, but I think we have the time. So it's a story, if you want to have the real beginning, because I've been asked that before, and to the best of my recollection, it's a mixture of two things. A lot of literature that I had very early in my life, which included everything from Shakespeare to mystery stories. And the mystery stories were very, very important to
Now, it's
me.
interesting. You're saying literature. You mean literary literature, not science books.
No, I mean literature. And there was this obsession in my parents' home with things like Shakespeare. I was supposed to digest Shakespeare very early on, but I was also allowed to read mystery stories. And the mystery stories were really very important to me. And I was intrigued by solving puzzles. And then I think the next step was solving puzzles that had nothing to do with biology, had to do with engines. I had a passion for car engines, and I took engines apart, and more importantly, I did drawings, plans for better engines of the future, where the valves would be and the camshafts and things of that sort, all pretty silly. But I think that if I want to know where my obsession with mechanisms in the brain comes from, I would say it comes from a mixture of the mystery stories and the engines. And then eventually I got much more interested in mysteries of the mind. And I thought for a long time that probably what I should be is a writer or a filmmaker. And then I remember quite distinctly that I had a wonderful professor of philosophy. He had been my professor of history, was then my professor of philosophy, and was superb, was a published philosopher, very, very smart man. And I told him...
And let me just, this is in Lisbon, Portugal,
in Portugal.
Where you grew up and did your school.
Yeah, it was in what is the best way of describing it, is a gymnasium. And one day I was asking him about whether or not I should become a filmmaker or writer, and I explained what I was interested in, this sort of understanding mechanisms of the mind, and he said, no, what you want to become is a neurologist. And he explained to me why that would be the path. And he gave me lots of papers and books to read about that. And after I did so, I was convinced, and I went to medical school to become a neurologist, which was a pretty odd thing, and people made fun of me, and they said, well, you're probably going to become a plastic surgeon, maybe in anticipation that I would end up living in Los Angeles.
That's right.
But I did not become a plastic surgeon. I became a neurologist, and was the right path, and it has stayed with me.
Very good. And so that explains the neuroscience. It explains the mysteries and the questions you've been asking. And we'll return to it at the end. But this latest turn in your career, to come to USC and with your wife start this Brain and Creativity Institute, what's that about? That sort of brings them all together again.
Yes, I absolutely, because I think, of course, I did meet Hanna in medical school, and turned out we had very similar interests, although we wanted to approach them differently, but the interests were similar. And she also was a neurologist, or became a neurologist, and for a long, long time we dealt with studies of different aspects of the mind, all the way from language and memory to consciousness, and emotion is a very important component of it. At a certain point, it became clear that, first of all, neuroscience was changing. And neuroscience, which traditionally has been about dealing with brain function, but always with an interest to solve disease problems, that neuroscience now could solve another range of problems which we can describe in the social space. Let's call them not the usual human pathology coming from brain diseases all the way to the psychiatric diseases, but rather social pathology. And we had a great interest in social emotions. We had an interest in the issues of social conflict, for example. What is the basis, for example, for moral systems? And it became clear that we needed a new setup to proceed. And the move here was exactly to be able to do so, to have an institute where you focus the research while continuing with a thread that has to do with brain disease, for example, with stroke, Alzheimer's disease, and other such conditions, we would have the possibility of studying the neuroscience of the social space. And that's what we're doing at the Brain Creativity Institute.
Very good. I'm Terence McNally. I'm speaking with Antonio Damasio, professor of neuroscience and director of the Brain and Creativity Institute at the University of Southern California, author of Descartes' Error, Looking for Spinoza, and his newest, Self Comes to Mind, Constructing the Conscious Brain. To learn more, go to usc.edu and type in Brain and Creativity. I don't give you the Brain and Creativity Institute website because it's too long. You'd never get it down. usc.edu, type in Brain and Creativity. It'll take you there. This is Freeform on KPFK 90.7 FM, 98.7 in Santa Barbara, streaming and podcasting at kpfk.org. And you can visit me at terencemcnally.net, Terence McNally, TERRENCEMCNALLY.net, or also found at aworldthatjustmightwork.com to learn about the show, guests, podcasts, transcripts. You can listen to podcasts there or at iTunes. You can sign up there or at iTunes to have it delivered to you weekly for free. You can also sign up there to get a weekly announcement from me telling you who's going to be on, what we're going to talk about, and some background articles. Or you can get that by emailing me at temcnally@mac.com. What has been... First, I want to establish for people just what has been your method. In other words, to study what you've studied, which is the things I laid out at the beginning of the relationship of emotion and the brain's development, the emergence of consciousness, the emergence of the self, all of these things. How do you study that?
Right. There are, we have a range of methods that we apply. Probably the fundamental method throughout most of my career has been the lesion method. The lesion method is something that was really invented in the 19th century by a number of very, very smart neurologists in Europe, and consisted of studying patients with neurological conditions, for example, stroke, who had lesions in one particular part of the brain and who, as a result, had a set of symptoms. For example, patients that would have damage in the frontal lobe and in what came to be known as Broca's area and lose the ability to speak normally and develop an aphasia, or develop another kind of damage in somewhere else in the brain and have instead another kind of aphasia called Wernicke's aphasia, or develop damage in the frontal lobe and have a problem of personality, or develop damage in the visual system and lose sight. So that system is really a true and right system. It continues to be, to this day, the gold standard of neuroscience investigation of systems.
So it allows you to look at damaged brains and what the results are of that isolated damage on the function of the brain.
So you can establish correlations between a lost function and damage in a particular area and conclude that that particular area is involved in a certain function. And once you map enough of the human brain, it is possible to understand that there are different systems that use different components to create a complex function, like, for example, a certain unfolding of emotion or a language process or memory or what have you. But this is not the only method. We have other methods available, some of which are also applicable to humans and have come to the fore, especially in the past 20 years. For example, functional imaging methods that use procedures such as positron emission tomography or magnetic resonance scanning that allow us to study not just patients who have suffered damage, but anyone, like, for example, you or me, who can go into the scanner, be asked to perform a certain task, a memory task or an emotional task, and as a result will have certain parts of the brain very activated that can be detected. And that, again, allows us to make a correlation between a certain mental process, a certain behavior, and a certain system in the brain.
And with that, I know one of the things which you can do is you can give people a specific task. You can look
Correct.
for a specific. You can put them in decision-making situations. You can
For
put them in
example.
stressful situations.
Absolutely. You have a huge range that really goes from decision-making in tasks that can involve, say, moral judgments or economic decisions, to tasks of emotion in different circumstances, different kinds of language process, memory, spatial tasks, and of course all the perceptual tasks that have to do with vision, hearing, somatic sensation, and so forth.
Okay, so I can see now where you begin with what is a cruder instrument, but very valuable, and now we begin to get more nuanced, more sensitive.
Correct. And the crude instrument was absolutely essential in establishing the ground rules, establishing the great big principles, for example, discovering that there were certain parts of the brain that had to do with a function and certain others that had to do with some other function that would not have been apparent had those studies not been
Let me
done.
ask a crazy question, which is that until that research was done and those things were found, had there been people who assumed or hypothesized this sort of different section for different function, or did we think of the brain as one thing?
Well, most of the time the brain was thought as one great big lump, 3 pounds of flesh capable of producing this great thing called the human mind. But in fact, there were people that thought otherwise. It turns out that they were not extremely smart about what they did, and they're known as phrenologists. And the phrenologists had the correct intuition that there would be certain parts of the brain involved in a certain function, except that what they proposed didn't make much sense. So, for example, there would be very, very complex functions, such as benevolence, that would be in one particular lump of the brain, and this was all detectable by lumps in the skull and other such nonsense. So the phrenologists got a very bad name and were booted out of the stage. But then came proper neuroscience in the middle of the 19th century. And at first, that proper neuroscience was accused of being phrenology.
Of course.
But of course it was not. And today, for example, in the kind of methods that we established in our labs, what we do is actually study many, many individuals so that we create groups and so that we have a possibility of making the method far less crude than it would be if you were just studying one patient at a time
Sure.
and, making theoretical interpretations about that.
Right, that worked for Freud, but not too many other people.
That's right. Yeah. Although, by the way, Freud started his career as a neurologist precisely at the same time. Freud comes into his career as a neurologist following both Broca and Karl Wernicke, very famous German neurologist. And Freud at the beginning wanted to follow that path. And it was only when he realized that the method would be insufficient at that time that he gave up and in the end opted for psychoanalysis and created psychoanalysis.
In other words, his questions, what he wanted to answer, couldn't be answered by that.
Correct. And it is a very important historical inflection. Because what he really wanted was to have precisely the same project that we have today.
That's what I'm thinking.
Yeah.
Yes, he does. And anyone who knows Freud's, great body of work, the stuff that people hear about the most is not humor, which was one of the things he covered, and religion, and all of these things in his later work.
Yeah, absolutely. And by the way, what was known at the time of neuroanatomy and neurology influenced his theories enormously. If you come from the side of neuroscience, you realize how that had a very major impact, for example, in the way he conceived of things like the id and the ego and the superego, which is really a sort of tripartite division that is not unlike some of the divisions that we're making today.
That's right. I'm Terence McNally, speaking with Antonio Damasio. He's a professor of neuroscience, and he's the director of the Brain and Creativity Institute at the University of Southern California. He's the author of his most famous book, probably, is Descartes' Error. And his newest is Self Comes to Mind, Constructing the Conscious Brain, and that's what we're talking about today. You can learn more about his work by going to usc.edu and then type in Brain and Creativity, and that'll take you to the Institute's page. If you could, and this is another one of those big questions, the first one on your path was a big question. Here's another one, which has been, I alluded to it in the introduction, but the evolution of your thinking through the course of those books, because it's pretty clear that one builds on the next, and then that takes us to the one that's
right.
just out.
Yeah. I think the critical development was coming to the conclusion that emotion and feeling were of an extraordinary importance in the construction of our brains and in the construction of what we call the mind. And that's something that did not come at the beginning. It's something that came, I think, sort of was forced upon me by the observation of patients that clearly had impaired emotional systems and had some impairments that I wanted to explain and could only explain by resorting to that impairment of emotion, which was not generally considered a very important aspect of their function or malfunction. So realizing the importance of emotion was critical, realizing that it is directly tied to what I call, for example, in the current book, biological value, this fact, this system that we have that will be involved in the regulation of life. We could put it in the following terms. We all face, whether we are an amoeba or ourselves, we face a major problem. We are alive. And if we are alive, we have the problem of regulating life. The big difference is that the amoeba doesn't think about it because it has no instruments for thinking and reflecting, whereas we do. But even so, there's regulation of life that is needed, and by regulation of life, I mean a series of processes that include, for example, the procurement of energy, without which we die, the incorporation of energy in our body, the changes, the transformations that are needed for the energy to produce the sources of energy to produce their effect, managing waste, and something very important is that every individual, even an amoeba, is in fact in a social setting. This is actually very easy to see if you study bacterial cells. They are in clumps, in groups, and they have a social setting that is made by other bacteria that are in the surround and that may be closer to them or further away. So part of the management of life includes a social aspect, and that social aspect does not pertain exclusively to us or to apes and wolves and cetaceans. It goes all the way down to single, very, very simple organisms. Now, the regulation that bacteria make of their lives is, in fact, coming by way of their genomes. Their genes are telling them to do certain things at certain points, given certain circumstances. Now, it turns out that we have precisely that same system in full operation and full glory inside our organisms, but lucky enough for us, we have another system that we have superposed on that, again, by the trajectory of evolution, and that is a thinking system. So not only do we have that basic homeostasis, that basic regulation of life that comes via the genomes, but we also have this other system, which to begin with was implemented by the genes, but then gives us some degree of freedom and allows us to think about what we're doing and say either no or yes to what the rest of the system is impelling us to do.
I'm going to cut in right now, although I asked for the evolution, because one of the things that really struck me in reading the first 7,500 pages of Self Comes to Mind was when you said that our body is made up of single-celled organisms.
Correct.
And that, to me, was one of those little mind blowers.
Right, and it is something that people miss all the time. Of course, everybody knows that we have these single cells making up tissues and organs and organ systems, but people forget that each of them is individually an organism with all the problems that we have as a multicellular organism. And of course, the life of every cell in your organism depends on the cooperativity of the systems and on them working together, because if they don't, then there are cells that are going to perish. They are dependent on this sort of general government that is available within the organism. By the way, the analogies to social and political organization are very clear. You know, we are in a socio-political body or organism. We have exactly the same levels. We have single individualized organisms, and then you have groupings, and then you have larger groups of management, all the way up to the higher echelons of control in a government in the proper sense.
One of the metaphors or analogies that you make at one point there is you point out the different elements of a single-celled organism and then say that in terms of those elements and those functions, it's very similar to what's going on in us.
Exactly. So a single cell is a sort of cartoon of our larger organism. So the single cell has a membrane, which corresponds to our skin, and then has a number of interior organelles that are corresponding to our different organ systems. And it even has a sort of master control, which in the case of cells with the nucleus is the nucleus, which contains the cell's DNA in great part, although there's some DNA in mitochondria as well. And all of that system is in an environment just like we are.
But the nucleus, once it emerges, is analogous to our brain?
Well, analogous in general function, not analogous in terms of the exact structure. No, and of course those cells, by the way, do not have a brain, do not have, therefore, a mind, and of course they don't have anything that looks like a neuron. And brains only emerge once a certain type of cell emerges, which is the neuron, a special cell.
And I want you to talk about that too, because again, this was new to me, probably not new to a lot of people listening, but that a cell, a neuron, has the properties of other cells,
exactly,
and the same needs, etc. But it has a few different elements, qualities that allows evolution to build on it.
Correct. And probably the most important is that neurons have the possibility of signaling to other cells, but signaling over long distances. So there is a prolongation of most neurons, which is known as the axon. And the axon can deliver messages which can be, just a few millimeters away or many, many centimeters away from the body of the cell. And those messages can come in the form of an electrical signal and of a chemical signal to the next cell. So it allows neurons to have an impact on other neurons and to have an impact on other cells of the body.
So in other words, until we have a neuron, cells have these different elements, they have these functions, but they cannot influence other cells. They can move further away from them, they can move closer to them, and the neuron actually responds to other cells and can affect other cells?
Correct. And of course, before you have neurons, you have some possibility of influencing other cells through what is basically an exocrine system. So you have the possibility of generating molecules that are extruded from the body of the cell and that have an impact on the environment, an impact, for example, on another cell. Maybe, for example, the system that we have as humans of pheromones is the residual of such a system, in which we can emit molecules into the air that potentially can alter the behavior of other individuals.
Wow. I'm Terence McNally. I'm speaking with Antonio Damasio. He's a professor of neuroscience and director of the Brain and Creativity Institute at USC, and the author of the newest book we're talking about is Self Comes to Mind, Constructing the Conscious Brain. You can learn more about him and the Brain and Creativity Institute and their work by going to usc.edu and typing in brain and creativity. Okay. I'm going to read a quote here. You say, "I've been studying the human mind and brain for more than 30 years, and I've previously written about consciousness in scientific articles and books, but I've grown dissatisfied with my account of the problem, and reflection on relevant research findings, new and old, had changed my views." So what are some of the scientific findings that led to that change, and what are the views that changed? And this is in this book, right?
Yes, this is in this book. And the findings have to do especially with the entire system that permits us to have feelings and the impact that feelings have in the generation of consciousness, quite specifically in the generation of the self. And then there are a number of findings that have to do with the anatomy and the physiology of both the cerebral cortex and another part of the brain, which is much older than the cerebral cortex, which is the brainstem. And there are facts about the way those regions of the brain are hooked together and how they do their job that have come to the fore in the past decade and that changed my views. For example, I used to think that although the brainstem was very important in these processes, somehow the cerebral cortex had the upper hand. And of course, I still think that the cerebral cortex is very important because without a cerebral cortex, neither could I say what I'm saying right now and map out my ideas the way I am doing, nor could you understand them. So, of course, it's not a question of living without the cerebral cortex. That would be absurd. However, none of this would make sense and could exist if it weren't for the brainstem with its very close hooking to the body and for the generation of feelings that occurs at brainstem level.
Okay, and the brainstem, just I want you to set up for us this difference between the brainstem and the frontal cortex, both in really where they are. Is the brainstem where the brain meets the spinal cord?
That is correct. So the brainstem is actually the long bridge between the top of the spinal cord and the telencephalon, what you normally call the brain itself, which is really made of the ganglia of the base and the cerebral cortex over it.
And then the cerebral cortex is the front part.
No, the cerebral cortex is all of it.
All
is
of
the
it.
entire mantle of the telencephalon.
Okay, so we get these two elements.
Exactly. And the cerebral cortex includes the frontal part, which is obviously in the front.
Right.
It includes the occipital cortex, which is in the back.
Sure.
And as well, it includes the parietal and temporal cortices, which are more in the middle and lateral.
And in terms of age or evolution, the brainstem is very similar to the reptile brain?
Yes, our brainstem is made according to the design of the reptilian brainstem. So it's very, very old. Of course, we have a larger brainstem than reptiles do, and we have a few more bells and whistles, but the basic design is the same.
And then you point out, going back to some of the method you talked about before, about when people lose certain functions or lack certain, and you point out that
there can be damage to the brainstem that very clearly, for example, impairs consciousness, and the damage can be so finely etched that you can have, for example, damage to the upper part of the brainstem in the front of the brainstem that does not cause alterations of consciousness, but you go a few millimeters back and it changes consciousness, and the result is that you are in coma or in vegetative state.
But what I was getting to was that people who do not have most of the cortex operative can still have
aspects of consciousness. Yes, absolutely.
And so that's one of these new realizations
Absolutely.
that led you to change your thinking.
Yes, and one new realization that is very important has to do with the sort of obligate closeness, which is more than closeness, is the real fusion between brain and body that takes place at the level of the brainstem. So the brainstem is the recipient of this bombardment of signals from the body about any part of the body and about any aspect of the state of that part. and at the same time has the possibility of signaling back exactly to those same places that were just originating the signals. So it's a very close looping that allows these two systems at a certain point to be almost indistinguishable in terms of defining a sharp border.
I mean, in a very crude way, the brainstem is both brain and body.
The brainstem is brain tightly close to the body.
Yeah. And the cortex, of course, is part of our body as well, but one can make more of a distinction.
Exactly. Yeah. There, in fact, one of the things that is so interesting is that the cerebral cortex has not, this is very typical of evolution, has not been charged with doing what the brainstem has been doing. And why should it?
Of course.
The nature is very lazy, and if we can do things with fewer parts, we do it. And if we can, a part do more jobs than it was doing before, we ask that part to do so. So that's the way natural selection works, by making certain things tick in a certain way. And the cerebral cortex is not primarily devoted to the regulation of life, but the brainstem is. It's the brainstem that houses our biological value parameters.
And biological value is a term that I hadn't come across that much, but basically, I'll give you what I think it means. It's that biological value is the regulatory interactions, the regulatory mechanisms that allow us to be alive.
Exactly.
Our temperature, our metabolism, all of those sorts of things.
Precisely. You got it.
Okay.
So in biological value in general is about the set of rules and regulations that must be followed for you to stay alive for as long as your genes will allow you to.
Right, and that point you make very clear, that in a single-celled organism, the same rules apply.
Precisely.
That you have genes, and those genes will dictate at a certain point when you will probably stop functioning.
Exactly, when the cell is going to become apoptotic.
And up you come all the way to humans, and those gene messages are still there, but do we have more freedom?
Yes, we do, because having had the possibility of becoming conscious, having had the possibility, and now I'm talking about humans exclusively, having had the possibility of judging the kind of trouble we're in, the trouble of being alive to begin with, all the drama that follows from being alive, because it's not just, peach and honey.
All our vulnerability.
All our vulnerabilities, all the tragedies that can befall a human creature, losses in the environment, losses of those that you are attached to, and on disease in the individual, and on. And once you realize all of that, you have the possibility of reflecting on that and intervening on the regulation at that level. So it's not just a question of letting nature take care of what it does naturally. It's a matter of intervening in the process and saying, well, maybe we can do something about it. And this is something that must have been very intriguing to see develop at some point in the history of evolution. Relatively recent. I put this more in the tens of thousands of years as opposed to millions of years, and it conforms to this notion that I explain in Self Comes to Mind of socio-cultural homeostasis. So in that sense, the Supreme Court is a tool of socio-cultural homeostasis.
Actually, it's a tool of the right wing, but that's another.
That's another story.
That's a temporary condition.
Exactly.
Hopefully.
Yeah. I mean, there are cancers.
Yes, there are.
There are diseases.
This is Terrence McNally. You're listening to my 2010 conversation with neuroscientist Antonio Damasio about his book Self Comes to Mind, Constructing the Conscious Brain. He's one of the pioneers who challenged the Enlightenment's vision of mind over body and asserted the role that emotion and feelings play in human rationality. One thing that you make very clear, and why I've spent so much time dealing with the single-celled and very much we've been basically in biological territory this entire conversation, I think, is because that's the ground. Right. That's the place where. But if you could, why and how do we have a brain, a mind, a self, and consciousness, if you can kind of build those, because they build one on top of another, and they all serve biological value.
Absolutely. They all serve biological value, and they wouldn't be there without biological value because, of course, the process of evolution, the process of natural selection is driven by biological value. It's all about life. It's all about creating organisms that can stay alive for a certain period of time and can pass on their genes to the next generation.
Before you launch into that, let me just tell people who just tuned in, this is the voice of Antonio Damasio.
With laryngitis.
It's the laryngeal voice of Antonio Damasio, and we're talking about his book, Self Comes to Mind.
So we have, so you have that problem of biological value management, and which is really the problem of life. And once you have brains, before you have brains, everything is under the control of genes that have certain policies that will be applied when. So it's all on the form of, if this happens, then do this. Once you have brains, once they appear in the scene, you have a possibility of improving the response system. So you have the policy, but now you have neurons to help you create certain actions. There's something that is very important that happens in animals that have brains and that have the possibility of action, which is something that is normally not possible for plants. One thing that I say in the book is that plants do not have the possibility, if they're not doing well in a certain place of the garden, of getting up and moving to another part of the garden.
Right, they can lean toward the sunshine, but they can't walk
That's
to
about
it.
all, exactly. And so they depend on the gardener. Well, we have other possibilities which have to do with action. With, you move to another place if you don't like where you are, and that's great. So a motor system and the possibility of action is really very important. And of course, very simple brains gave that in spades.
And very simple brains emerged at the level of what organism?
But take, for example, a worm.
Okay. Okay. Single cell don't have it. Worms do.
Worms do.
Now we got brains.
And
okay.
You can get a certain number of neurons. Sometimes you get a ridiculously small number of neurons, something like in the hundreds, and it's enough to make the creature crawl and move about and find another place. And actually have very interesting social behaviors too. But that's another story.
Right.
Okay, so once you start having a brain with a mind, what you do is have this great possibility, which is really a major change.
Now, you just said a sentence. Once you have a brain with a mind, does a mind automatically come with a brain, or does a mind emerge later as well?
The mind emerges once the brains are capable of making maps.
Okay.
So
maps.
Maps. So instead of just having what I call dispositions, which allow say, a ganglion of neurons to get a signal and send a command to move that leg. Now we have something different. We can have another part of the brain that actually pictures an object that is attacking you, as a result of which you're going to move the leg.
So more than just feeling it, which the worm might.
Yes.
And so the worm might move away from something it feels.
Yeah.
The mind emerges when we have the ability to map and visualize, and I use the term, it might not be visual, but
quote,
it works. Visualize things outside ourselves and inside ourselves.
And of course, the great value of brains came from the possibility of making maps, and therefore allowing you to picture in detail the source of either a great opportunity or a threat. So that's incredibly important, and it's so valuable that, of course, evolution is going to seize upon it and select that. Now, at a certain point, so by now we have brains and minds,
right,
and we have optimized the system of response to the world. We take better opportunities, we stay away from threats with,
We manage life better.
And we survive more, and we pass on those genes, and we become, nice and cozy with our brains and minds. Now, at a certain point, if you have the possibility of representing your own organism in great detail, and if you have the possibility of generating a feeling for that organism, then you can develop what I call a concern for that organism, which is one step up in the optimization of the response. Because now it's not just that you can respond better, is that you're going to be concerned with responding better because you care for this darn organism that is yours.
So the two criteria for that were the ability to map it.
Yes.
And the ability to map it internally. And what was the...
The real turn is the feeling.
Ah!
The feeling is the passport into connecting with your own organism.
Prior to this, the organism didn't feel it?
Well, it felt in very abstract terms. I think it feels in ways that are probably not that different from the ways of representations that you could even implement in a computer. Now you have something more complex that connects a certain state with the signals that are coming from the body and that define the state of your flesh.
Okay, so it's when you can not only map it, but feel it, then what happens?
Then you become very concerned with that and you achieve this new step, which makes you, for example, extremely aware of good states or bad states, for example, pleasure versus pain, and allows you to control your responses in a way that you can favor pleasure and avoid pain.
At this point, when you have that felt sense and that concern, this is the development of the self?
Yes, that is sort of step one of the self.
And the self is, I now have a sense, not thinking, but I have a sense that I am, and I am alive?
Yes. So it gives you what I call the spontaneous access to the notion of existence. And by the way, you don't need to think about it. What that will do is organize your mind, even if you are not a terribly thoughtful, reflective creature. It still organizes your mind in relation to that problem that now has been defined in your brain, which is the problem of you being alive and having, for example, pain.
And that then sets the stage for consciousness.
Correct. I think that's it's extremely crude and it would be foolish to sort of make sharp boundaries for consciousness. However, I would say that consciousness begins there. Consciousness begins when a very simple self emerges, a minimal self that is tied to these primordial feelings. And you have, so it's primordial feelings, the minimal self and consciousness, they all are part of the same tissue. Mm-hmm. What I think consciousness is not is just a pure mind with images. That is mind, and I would prefer to reserve the term mind for that, but not necessarily a conscious mind.
So, three other things, and it's interesting, just the distinction you just made led me to it. Now, the distinction or the evolution of feeling, emotion, and thought.
Okay. So, emotion is really an action program. Emotion, and the root motion there is not a coincidence, is about an organism acting.
Wow.
It's all about action, and it's all about a set of actions, really a concert of actions, a mini concert of actions. Feelings are about the representation of the results of those actions on the organism. So when you have the emotion fear, a number of things happen. You have your heart beating in a different way, your gut contracting, your lungs producing a different rhythm of respiration, cortisol being spritzed into the
fight or flight.
Exactly. All
response,
of those things.
Now,
those are all actions.
That's what's interesting.
But
You said emotion is action. What you mean is that how you know you have the emotion of fear is because these actions happen.
Correct. And you can study it very objectively. Feelings, and by the way, emotions are public. When you have an emotion, even if you try to disguise it, something is going to come through because they're actions, because they're public, they're behaviors.
All those things that are changing in your body change the look and feel of you.
Exactly. Your facial posture, for example. Right. Your facial mask changes in fear. Your posture changes in fear as well. Eyes, mouth, and so on. But the feeling is private. The feeling is exclusively the subjective aspect of that process, is the brain's take on what is going on in the body at the moment that you are having the emotion of fear.
Okay.
And of course, this is, we're constantly making enormous mistakes when we confuse one with the other, because very often people talk about emotions, but they are really referring to their feelings, and they can be talking about feelings, but they're referring to their emotions. Our language has become extremely loose, and I don't want to be pedantic and tell people to use terms in a precise way, but it helps, and in research it's indispensable.
Sure, of course, of course. Now, what I realize is that getting to the point we've gotten to now, we now have about 7 minutes left. Amazing.
Okay.
But we've walked through this territory pretty carefully. I'm speaking with Antonio Damasio. He's a professor of neuroscience and director of the Brain and Creativity Institute at USC. And we're talking about his new book, Self Comes to Mind. I want to skip a huge bunch and ask you, having come to all of this, what are the questions that you're pursuing right now?
Well, there are a number of questions. For example, we're extremely interested in the whole matter of social emotions because, of course, when you think of emotions, you think about the primary emotions like fear, anger, sadness, happiness, disgust. Those are very simple emotions that are widespread in living creatures. You can go all the way down to invertebrates and find some of them. But then we have in more complex organisms, and definitely in humans, a class of emotions which is called social emotions. Examples: compassion, admiration, pride, shame, embarrassment, contempt. I'm just giving you some of them. And what is so interesting about those emotions, which, like the other emotions, are set in our brain systems by our genomes, is that those emotions, to begin with, embody some moral values. So, for example, when you have the emotion of compassion, you automatically do for someone who is in a certain predicament something that will be good for that person. The emotion is a deployment of actions that are going to have a positive result for someone else. When you have the emotion of guilt, for example, you have, and of course that acts as a corrective.
Now let me just, again, not to get pedantic, but when you're using emotions now about things like guilt and compassion, the same definition holds true? They are still, they aren't mere feelings, but they are actions?
They're actions and then feelings.
Okay.
Yeah, because any emotion, provided you have the brain capable of doing it, becomes a feeling. And so any emotion becomes a feeling because you're going to perceive the action that you have just taken. And for example, in guilt or shame or embarrassment or compassion, you have a number of actions that you have. If you have someone that is admiring of somebody else or is compassionate about somebody else, their facial postures, body postures, that are assumed automatically in relation to the person that is in a predicament. Now, what I want to say is that because there are these sort of incipient moral values in these emotions, we want to study them as a base for what in conscious and deliberative individuals become ethical rules. So we have something in our biology that then, if properly managed in a culture, becomes what we call ethical rules and can be applied in justice systems.
Let me throw in the last question, and you'll only have like 2 minutes on this, which is kind of what I referred to at the top, which is it looks to me like Karl Rove and Frank Luntz looked at emotions trump facts, decisions are all colored by emotion and so on, and that through the use of television advertising and appeals to emotion and inferences of threat and so on, we now have what looks to me like this most powerful nation in the world governed by pretty simplistic, primitive things. How do we get out of this mess?
Well, we get out of this mess by knowing exactly how it works, because the best vaccine against all of those manipulations is knowing what is happening biologically to us, what is happening when we have those emotions, for example, of fear or of delight, and to get the possibility of resisting the influence of those emotions and allowing reason to play appropriately. Because the same way, emotion is originally the basic form of reason. When animals have fear, there is a rationality to that fear. The fear will protect them from a threat. Emotions in ourselves are just that bottom part of the system of reason, but we have developed all the other forms of reason that have to do with knowledge, with logic, with reflection. And it is those systems that need to ride over emotion. So it's not the question of denying emotion, as the rationalists did at some point, and say, well, it's all bad. Well, it may be bad or good, it doesn't make any difference. It's here.
It's active, it's powerful.
It's powerful, we need to deal with it. So we need to recognize it for what it is. We need to recognize it for the role it plays in decision-making, and then we need to be vaccinated against it by reason. We don't need to take injections. We just need to understand how it works.
Well, you don't have time to respond to this, but it seems to me that I teach about story, and one of the things I say is facts won't trump a story. You have to come up with a better story.
Yep.
And I have a feeling that unless those who we think are inclined to our better angels learn to link those facts to emotions, that rationality to emotion, we won't succeed in shifting things.
You know who said that? Spinoza said that the only way of overcoming a negative emotion is by having a more powerful, positive emotion. You have to work through emotion. So the question is to find a combination of rationality, a combination of good reasons and good emotions.
And get those together and use them. I've been speaking with Antonio Damasio. He's the director of the Brain and Creativity Institute at the University of Southern California. We've been talking about his newest book, Self Comes to Mind, Constructing the Conscious Brain. To learn more, go to usc.edu and type in Brain and Creativity. You can listen to this week's conversation and many others anytime during the week by linking to our podcast. You can do that at either iTunes or terrencemcnally.net, TERRENCEMCNALLY.net, or aworldthatjustmightwork.com, same website. You can also sign up to have it delivered to you weekly for free, either at iTunes or at my site. You can also sign up at my site or by emailing me at temcnally@mac.com. To get a weekly announcement telling you who's going to be on, what we're going to talk about, and some background on those issues. This program will also be archived for the next 90 days at kpfk.org. Check audio archives, scroll down by date and time. Thank you to Devin Jordan, my engineer, Stan Mizrahi and Mark Maxwell in production, Matt Perez in traffic, and to you, my listeners, I look forward to being with you again next week. Stay tuned for Maria Armoudian. She's moved from Thursday afternoons to Sunday afternoon. And she's passionate, well-informed, and also looking for solutions. Finally, thank you to Antonio Damasio. Keep up the good work.
My pleasure to be here.